Glycolysis. So it is divided into preparatory phase and the payoff phase. It is a common step in aerobic and anaerobic respiration. Now, glycolysis, the preparatory phase starts from glucose to glyceraldehyde 3 phosphate, and the payoff phase starts from glyceraldehyde 3 phosphate to the pyruvic acid. Now, we'll learn the preparatory phase, then the payoff phase. So preparatory phase, the glucose gets converted into glucose 6-phosphate in the presence of enzyme hexokinase and ion Mg2 plus. Now you must be thinking how phosphate, one phosphate of ATP is used, and that's why it is converted into glucose 6-phosphate. So you must be seeing ATP getting converted into ADP, triphosphate, diphosphate. One ATP is used, so it becomes diphosphate. Glucose 6-phosphate gets converted into fructose 6-phosphate in the presence of phosphohexose isomerase. There is just a conversion of isomer. Glucose and fructose are isomers of sucrose, and fructose 6-phosphate gets converted into fructose 1,6 diphosphate. Diphosphate, because one more ATP, that is one more phosphate molecule, is used. One more ATP is used, it gets converted into ADP in the presence of ion Mg2 plus and enzyme phosphofructokinase. Fructose 1, 6 diphosphate gets converted into glyceraldehyde 3 phosphate, that is PGAL in short form, dihydroxyacetone phosphate, that is DHAP, that is DAP. Now, as soon as it gets converted into dihydroxyacetone phosphate, it soon gets converted into glyceraldehyde 3 phosphate, thus giving us glyceraldehyde 3 phosphate, but 2 molecules of 3 carbon. 2 molecules of 3 carbon. Here we come to an end of the preparatory phase. Clear? Now we start the payoff phase. Glyceraldehyde 3 phosphate gets converted into 1,3-bisphosphoglycerate in the presence of enzyme triose phosphate dehydrogenase. Here 2NAD is used to give 2NADH, 2NADH plus H plus in the presence of ion Zn plus, Zn2 plus, Zn2 plus. Now 1,3-bisphosphoglycerate gets converted into 3-phosphoglycerate. 3-phosphoglycerate in the presence of phosphoglycerate kinase, and here 2 ADP is used to give us 2 ATP back. 2 ATP back. 3-phosphoglycerate is converted into 2-phosphoglycerate. There is just a change of position from 3 to 2 in the presence of phosphoglycerate mutase. Phosphoglycerate mutase. 2-phosphoglycerate gets converted into 2-phosphoenol. 2-phosphoenol pyruvate. 2-phosphoenol pyruvate in the presence of enzyme NLOase, and it gives out 2 H2O molecule. 2 H2O molecules. 2-phosphoenol pyruvate gets converted into pyruvic acid in the presence of ion Mg2 plus pyruvate kinase, that is an enzyme, and 2 ADP is used to give us 2 ATP back. So at the end we get 4 ATP, 4 ATP, and here we get 2 NADH. So 1 NADH gives us 3, 1 NADH, let's do the calculation. 1 NADH 2 gives us 3 ATP. Therefore 2 will give us 2 into 3, 6 ATP. And we have got 2 molecules of ATP in the seventh stage, and one more, and 2 1 plus 2 in the 10th stage. So therefore it will be converted into 4 ATP. This and this will get converted into 10 ATP, but 2 ATP were used at the start. 1 year. It is in the first step and the third step. So it will get subtracted from it, and therefore 8 ATP are formed in glycolysis.